Hey everybody, this is Larry. This is me and doing Advent of Code day 10, I think, hopefully. If not, forgive me. I've been climbing all day. But yeah, I'm here in Tashan, the top of the Tashan Observatory or observation deck or whatever. And you can see it's very high up. It's very nice. It is in the Alishan area of Taiwan. I'm I'm very happy right now. So sorry for that. The video is a little bit late, but yeah. Anyway, and you'll get to see. Ooh, wow! It really fogged up behind me really quickly. But you'll see the rest of this now. Thanks. Yeah, hope everybody likes the intro. Yeah, day 10. Let's do it. My disclaimer is that my internet's really bad today. Just been kind of running a streak of dubious luck with the internet. You know, it's been way good the last month or so. It has good speed, I think, but the latency has been kind of bad. So we'll see what happens. Okay, am I ready? Hope y'all enjoy. I'm still in Alishan. I'm at a hotel here. It's beautiful here. You get a chance to come here, you should take it. Anyway, all right, let's do it. Am I ready? Let's find my. Where's my other window? Sorry, friends. Technical difficulties. Where is it? Dun, dun, dun. Not too many windows. There it is. All right. All right. 3, 2, 1, go. Oh no, one button. What is this? Okay. Someone told me that triple clicking it works, but I have trouble triple clicking. All right, let's go. Hot springs. I went to hot springs lately. Okay, let's see. Yeah, you have pipes. Yeah. Okay, so okay, that's a pipe. Sketch looks like this. Okay, so we have to. Yeah, that is a lot to read, but okay. So find the S. Is there an S, or you have to find the S? No, there's an S. Okay. And then S is always an F, or is this? I see. So S can be anything. All right. Well, this is kind of an annoying problem. I mean, I don't think it's that hard. It's just a lot of annoying things. And I don't even know if I'm understanding it correctly. I think that's the biggest problem. But okay, fine. So we just get the board, and then now, yeah. Let's just pause the board real quick for S. Terrible, but okay, fine. Okay, and then now what? There are a lot of different type of pipes. We could try each one, but still. Okay, fine. Yeah. I am not fast at all with this one, am I? 4 minutes and I have 2 follow-ups. Okay. For C in this thing, the J7 F. Oh, S is not it. There's no pipe in this tile. There is a pipe in this tile though, so okay. So one of the 6 things. This isn't quite aboard. I should there's probably a better way to write this. But yeah, and then now you see, and then if good, then okay, whatever. No, something like that, right? So then now we can now we have to do this, right? Okay, so if guess I just write it out. Up and down. Maybe I'll just write that's confusing, but okay, fine. Up, right. J is up left. 7 is left down, and F is right down, right? Okay. And now directions. Okay. So now we have these things, and then now, okay, so we start at SXSY, right? What am I doing? Okay, so and then this is part 1. Maybe I'm just doing it dumb. Okay. And then now we want to deck Q dot maybe just set it at infinity instead. And good old def breadth first search. And now for D and naming things aside, count the direction. I don't know. Directions sub XY for. So this is DD directions of CD. It's going to give us DXDY, and then X or new X new Y is equal to X plus DX, Y plus DY, right? If equal to distances of X, Y plus 1, right? I guess that's the same thing. Good. Okay, but then now, how do we determine whether there's a loop? This is so hacky. I don't even know. Do I want to do this way? I guess technically, fine. And they should only do two things, right? At every loop. So that means at the frontier, right? So that means if the last two things are connected to each other, this is so not kosher. That's why I'm like hesitating. Because this is a grid. Because this is a grid with two, it's an Eulerian cycle, so that means that the last one is always going to be odd one out. So that means that it's going to be equal to if this is the case, that means that there's a cycle, right? Then now we can return this. Otherwise, we turn it to 1 maybe? I don't know if this is true. Say what? Say what? What? Why is this returning none? Am I really that bad at this part? Oh, there's no S in my small thing. Because, I don't know. This is, how many times do I have to click on this for this to copy and paste? Okay, fine. I think they messed it up on that one, but okay, fine. For CD in direction XY, not that, is it directions? No, it's how it's called, is board of XY and then directions of this. Okay, what? That doesn't make sense. Okay, so that's good at least. Maybe, oh, because of the loop. Oh, period. 4, 6, 8, 0, 6, 8, 20. There's a race or thing. Even if it's right, we'll see. And of course now I have lag, so am I even connected to the internet? Tell me why. I can't even submit twice because if it's wrong then it would just be like, nope, you're wrong. Twice. Timed out. Oh, there we go. But that's good. I mean, lag part is not so good, but alright, let's just do part 2. Okay. I don't know how to do this for a grid. I think in a normal case you do the inside outside thing, but I think this may be a little bit tricky to do. Okay, so let's say we have the loop. The loop. What does that mean? For part 2. Okay, so what is the starting thing? I think that's the part, right? So the starting thing is, I only have to solve for my case, so okay, print C and this, right? So it is up down, so it's going to be either the left or the right, and then we do a breadth first search. That's not good enough, is it? Because of this squeezing thing that they had an example of. Because let's say we do this one, we can't breadth first search our way to the other one. I mean, I think the easiest thing to do is just count the number of of things. Okay, yeah, let's just do it that way then. Ray detection things. Okay, so we do this. Now we want this, and then now we want to. So now we have a good board. What do we do with the good board? Right. Okay, so then now we want scene to happen. We returned this answer already, so okay, so let's just say we return scene instead. Otherwise we return none. If now it's not none, then that's good. Let's make sure that it prints real quick. Okay, and then now what we want to do is just cast from left to right, because then now we return all the things that we've seen. That's actually we don't actually return all the things that we've seen, do we? Because of this thing. So we actually need to put scene here. No, we can just return distances actually. Okay. And then now we'll just go for, yeah, from left to right. And then now, so going from left to right, if distances of ij is not infinity and directions of board of ij, if this contains a vertical thing, yeah, then we flip. So then now we start with outside is equal to true, and then now outside is equal to not outside, and then after that, wait, do we only count the dots? I guess we don't only count the dots. Wait, do we only count the dots? Any tile that's not part of the, okay, fine. So then now, yeah, so then now if it's not, if this instance of ij is equal to infinity and not outside, then we count it. Is that true? Is this sufficient? Oh no, I don't really return this. Oh, I just go in now. Okay, fine. Distances of ij int object is not. Do I return something weird? I return -1 for some reason. Oh, let's try this one. I cannot triple click for the life of me. So 5, which is not true. What are the 5? Or what are the ones that they think are the 5? No, whoops, that's just one for test. 5, 5, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. Oh. Okay, so I'm wrong on this one, because it counts this because it has an odd number of vertical things. Man, This part I don't know how to do. I guess I do know how to do. You just treat the vertical things as how do I write that? Okay, so this is also wrong, I think. I did it the other way around. Whoops. Wow, this is just actually really wrong. But I meant either of them. So it should be like a set intersection thing. Wow, this is pretty bad. But okay, fine. So either this or this. I mean, it's still wrong, I think. But what is part 1? Oh, part 1 is some weird thing. Okay, fine. Basically, the idea is that it was UD. Okay, fine. What do I have this map for? Okay. Okay, so then now, I mean, then I don't need, okay, fine. If it's not infinity, then, if, okay. Cell is equal to directions upward of ij, or just ij, I think it's fine. Okay, so if cell is this thing, then outside is equal to not outside, but what if it's the other ones, right? Basically, you need 2 to flip sides. That's awkward to write, but okay, fine. Half 0, 0. Okay, fine. Else if cell is equal to well, if cell is in basically not this, then half is equal to 1. If half is equal to 2, then outside is equal to not outside, and half is equal to 0. Is that true now? It's way awkward, but oh yeah, whoops. Where is it? Okay. Okay, well, this got even worse. So, alright, 110. Oh, because now this. Oh, because it matters which side. So we can't just do it this way. Hmm. How do I handle this? Okay. Did I just do the enumeration? Would that even help? Outside, you be on the inside. I see, because you're counting up and down, so it's not half like this. If it's not, then we look at Okay, now maybe it's up. It goes to down is equal to force, right? So then now we see this. Then now up is equal to not up, down is equal to not, and we can actually generalize this, right? So if distances, no, not distances, what is that thing I call directions of cell, if u is in here, then up is equal to not up. If d is in directions of cell, down is equal to not down. I mean, this is, but then now what if they both changed? This is hard to figure out the logic for. Okay, because you basically and nothing changed. And then basically this is saying, so they both start at force. They're both true. Then you're on the other side, maybe? I don't know if this is right, but YOLO. Hopefully my internet is fast enough to at least give me a wrong answer quickly. I guess I could keep looking. Yeah, you don't have to discipline to keep looking, but is this right? I mean, it's right for the other example, but okay, that's good. But this is so annoying because of the lag, but I guess if you spend 30 minutes, the lag isn't really a big issue, but wait, am I still recording? Whoops, sorry, friends. Yeah. Sorry, I'm just so tired today. I forgot, and I'm just like trying to figure out what's going on. Okay, yeah. So let me go over my solution real quick. Sorry, friends, but I'm really tired. Clearly. Yeah. So the idea here is actually a concept in computational geometry. And it's actually exactly this, though I'm looking at my form, and Core actually has a smarter way of doing it, which I should have done actually. Or, I don't know, maybe today's just not a smart day anyway for me. But yeah, I'm just drawing this. Basically, the idea is that you have some, polygon. It doesn't really, I guess this is a terrible polygon. But yeah, you have some polygon, and this is in general. It doesn't have to be convex. It could be some weird shape. Pretend they're straight lines. And the idea here is just a point, what they call a point in polygon test. And the idea here is that, okay, let's say you want to see if this point is in a thing, or even this point, right? So you have 2 points. And the idea is just, and they're easier conventions like shooting straight up or shooting straight down or something like this. But the idea is that you shoot away outside. And basically, if you're inside, you're gonna bounce off, well, not bounce off, but you're going to pass through odd number of lines. And if you're outside, you'll pass through even number of lines. That's basically the core idea that I try to employ here. It's clearly not the fastest idea, but it is an idea that let me take a look at the leaderboard actually real quick. I'm just curious how fast people got it. Oh, Jimmy went down. How did I do? 16 minutes. So part one not so fast. Oh, I would have gone. I would have gone 60th on part two. Huh, that's not bad. Huh. Despite feeling slow. Yeah. Basically, that's my idea, and then we'll go over the code now. Yeah, the idea here is actually let me bring back the paint. But yeah, the idea here is that well, first, this is the core idea that I was trying to do. The point in a polygon test. Like I said, I think Core's idea is way smarter if you're able to do it. But if you're able to think of it and just do it, because I was trying to think of it that way with breadth first, and I've used that technique before, but didn't think about it today. But the idea here is that the hard part about this particular problem is degenerate cases, right? So because I'll use straight lines. You can think of it as just a polygon, but they're all like rectilinear, right? And that's basically kind of the idea that I try to do. Let's make it a little bit more interesting, right? And again, a point in polygon test, or initially what I wrote was that, okay, well, for every cell, and you could kind of think about it in the way that I think, for every cell, I look at the cell and how many up vertical lines have we passed, and basically now it goes to the outside, and then it goes to the inside, outside, and so forth, right? Then these are all count good, right? And then you go outside. So that's the core first idea that this is the first idea that I had, and I implement quickly. But the idea here is that the tricky part that I was debugging for a while is the degenerate case, right? The degenerate case is that, okay, let's say you're here, you want to go here. So I drawing with the touchpad, and now you're here, right? If you're here, then now how do you handle these? Let me change the color real quick. How do you handle this line, right? And that's basically and how do you keep state about what's afterwards from here to here, right? Because okay, that if it's a line, then it's not inside or outside, so you don't count it. But then what happens afterwards? So then the idea that I had was that, okay, you can actually break a pipe down to two components. So an up component and a down component. And basically now, if a cell tries to, we do a query and we try to go through, it only breaks through if you got the up component and a down component. And as an example, you can think is well, like here, right? So then now you have this corner and this corner connected. Then now, and this is just case enumeration in my head when I was doing it. Basically here, whatever, I mean, you could say this is outside, and then if you go past this path, this is also still outside, right? And of course, this is also true if this is inside, you go through the path, and it is still inside. So that's basically the idea here. And if you can't go through the cases, and that's basically what I did in my head for a little bit. You could, for example, if you just had this, then they're on different sides, right? So that means you could kind of see it visually that if this is on the inside, then the other side will have to be on the outside, and so forth. And then you kind of just enumerate those cases, and that's basically what I try to do with my code. Do I need to go explain part one? Let me explain part one first, actually. I think I kind of assumed part one was doable, but maybe not even. Yeah. But basically, the idea here is that I used a couple of ideas with just encoding it. So this is just purely to save typing. We have directions and then d directions, so that this gives us dx/dy. This gives us the two directions that you can connect to given the corner of a thing, right? And then now for the good. Okay, so then here, as I said, I just brute force six of each of the six different pipes, and if you know, in an abstract way, if this gives us a good board, then we just return we just return the number. And here we just use purely a breadth first search. The idea is that you just kind of keep on going from the starting one to the left, one to the right, and then you loop around. And the idea with this being the termination point is that I made a I recognized that in a grid, if one of the cells is 0, then the other one has to be a even number, right? Because you have 0, 1, 2. Because in a grid, if you add a cell, you have to add 2 cells to extend the path. So that means that the farthest cell is always going to be even. So and if that's the case, that means that there's one cell in which you know, like for example 0, 1, 1, or 0 is next to the two 1 cells, and then the farthest away cell is going to, let's say it's x. That means there's going to be 2 cells of x minus 1 next to it, and that's only true for this one case. So because if you look at the x minus 1 cell, it will be next to the x minus 2 and also x just x, sorry, right? So that's my thing, and this is breadth first search. It's going to be fast enough, and it's blazing, right? So part 2. So let's say you already got this using breadth first search or some other idea, doesn't really matter. You have this, and then now for part 2, the core idea that I said is the point in polygon test, but yeah, first of all, some bookkeeping is that here I return the distances instead, so that basically, if it's not infinity, you could consider that as the border of the cycle. So that's basically one of the things I did. And then here, this is what I said we did, right? Which is up and down is equal to force, and then that means that when you begin, they're all going to be on one side. Well, you're going to be on the outside, and if you encounter both up and down thing, then you go on the other side, which is the inside. So if up and down both true, then you count, you goes to 1. And that's pretty much all I have for this one. Yeah. Part 2 is kind of tricky for sure. And I don't think the way that I did it is easy to understand or even derive. But yeah, you know, that's all I have. Let me know what you think. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.